Okay, welcome back everyone. We'll continue with the topic neural network as a directed graph. See, you have networks viewed on directed graph. Very simple and easy module. So the basic idea of me covering the topic is like every module, let us complete the half, which is easy part. So the ones which I have highlighted over here is the easy one. So XOR, heuristic, and this what is that? This is not that easy, but backpropagation, differentiation, algorithm, batch learning. This is batch learning is a easy one, and online learning is also easy, but this backpropagation is like complete big theory explanation. So like I didn't consider that for studying, but if you study this for first and then go for backpropagation at the end, you just have to remember the equations function. It's easy. And talking about module 3, the easiest module I believe, next to module 1. So this is the easiest module 1, then module 3 comes second. Then in module 4 you have like easy types, like except for this one topic, all other are like very easy one, and the first 4 topics are very easy. And module 5 we have this recurrent neural network is a very lengthy topic, but apart from that all the other topics are very easy, so you don't have to worry anything. Talking about neural network use and directed graph. So see, let me just draw something. So we have seen this is a graph, I mean this is a node, okay, going like this, okay, directed graph. So now this becomes a directed graph. So this is the node, this is the edges. See, edges are nothing but the links. Nodes represent signal or computation points. So they might be like just points. So one point like this and then go like this, etc. like that. A radar link arrows shows direction of signal flow. So this might have some input value, and while going to the direction, they might have some weight values and all. That's nothing but directed graph and all. So representatives used to show how signals move through network clearly. So in a neural network, how the signal is actually flowing from which node to which node, from input to hidden layer, from hidden to output layer, or is it coming back like feedback from output to hidden layer again. All these things consist in neural network. So that's why we need the direction for that. So we have some example over here. This is some directed graph example, node and edges. So this is the link we said. I think I should erase that. Okay. Then xj towards y of k with the weight w of k. The link is carrying w of k. So what happens? This and this will be multiplied. But if you have xj of sigmoid function, then this will go inside this. So y of k is equals to sigmoid function of x of j. Then you have two arrow coming towards one arrow. That is when this and this will be added plus. See, it's very simple. If from one it is going is the same. Okay, so this is equals to that plus that itself same. So now suppose, okay, there are like four things are pointing towards one, and this is pointing towards and then two. Okay, so there were four nodes, synaptic links pointing towards one, and then this is pointing. So here what is happening? Each individual this link is right. It is actually passing to this. All these four are individually going to this and this as well. Okay, we'll see that here. So types of link: synaptic link and activation link. Which you saw here is a synaptic link. Which you saw here is the activation link. See, meaning multiply input by weight, apply squashing function. So multiplying the input with weight, applying the squashing function for input. So that's simple. Okay. Then we have a diagram over here of signal flow graph of a neuron. Okay. So this is the actual graph, and then here's the architectural graph. Here we don't have weight and all. You're just having the input and output. That's it. Then you have rules for signal flow graph. This graph itself, for this graph, we have some rules. Three rules. One is direction rule. Signal flow only in the direction of the arrow. So wherever you put the arrow, at that direction itself the signal should flow. So it's not like, see, if I do like this, here is the thing, here it is like that. Then I did like this. So here there is no arrow, but here, so it doesn't mean that it is going here. So wherever the arrow is, that side only it is going. Here it might be something different, but if there is no arrow, it's not flowing in that direction. Summation or fan in. So there is one fan in and fan out. Node signal is equals to algebraic sum of all incoming signal. Fan in the sense multiple nodes to one node. Fan out means from one node to multiple node. We can take example from here. Okay, let me just erase this part. Now see here, four nodes are giving to one. This is fan in. So this part is fan in and this part is fan out. Simple. Keyword fan in, fan out, algebraic sum. So they have to mention this keyword such that you will get marks without even reading the answer what you have written. Architectural graph of a neuron. There is one thing. A neural. So actual definition of a directed graph. Neural network is a directed graph consisting of nodes with interconnecting synaptics and activation link. So instead of talking interconnecting with edges, you are talking about two links. Instead of edge, you are calling as links. And what are those links? One is synaptic link, one is activation link, and it has four properties. So every neuron will have what? Synaptic link, bias function, and activation link. Bias is nothing but that b of k, right, which will be added to the uk wala thing. So this is not b, this is u. Okay, so okay, then you have synaptic link weight. So each synaptic link will have its particular weight. We saw here the weight can be some actual weight, or it can be some function, it can be some other output as well, it can be feedback as well, it can be input as well. Okay, and then what is the fourth property? It weighted sum defines included local field, that is u of k. Weighted sum defines induced local field. I am so sorry, induced local field. Activation link squashes induced local fields to output. So this what it defines is UK, and then plus we'll add B of J, KJ. Then it gives us V of J, and then this thing is squashed by activation link, inducing the local field to output. Complete versus partial graph. Single flow graph complete shows signal flow of inside neuron between neurons. So this is the one, so complete signal flow graph. But you have partially complete shows only layout. So from input to output, we can talk about both the things to cover the paper. Comparison table, mandatory representation, block diagrams. Okay, so this is like overview of whatever we have done so far. It's not like for writing in the exam, but to understand what to write in the exam. Block diagram shows what? Weights, adder, bias diagram. What is the weights? This is the first topic, that is the model of neurons, x, y, and all. Adder is nothing but that summation thing, right? Where the u of k will be determined. Bias is b of j. Activation, that is a stigmoid function. See this. Then best use neural model plus equation. Then in signal flow inside plus between neurons rules, directed graph plus rules. Then architectural graph only layout network. So this is three main things which was asked in this both the topics. Now mark answer writing exact pattern. So see, you have particular things. We write three elements plus bias. If the question is explain model of neuron, what you have to do? Three element plus bias keywords. Write three equations: uk, vk, yk. How uk is formed? Summation of j equals to 0 to m. Then you just write in the bracket w of ij into x of j. That's it. It does everything. Then mention bias as x naught plus 1. This is nothing but where you don't want bias to be added separately in uk plus j, but instead what you will be doing here, you will be giving weight itself as bias, so you don't have to add bias later. Mention activation function types: threshold plus sigmoid. We saw in the beginning of the notes itself, we had two activation links here. Where it go? Yeah, see here, one threshold and heavy side. So here if v is greater than 0 or less than 0, then you have stigma, that is 1 divided by 1 plus exponential exp, that is minus av. You can don't write like this, but write like this. In the textbook it's written as it is itself. Then what do we have at the end? That's it, right? We don't have anything else. Instead of wasting time, we'll move in the next topic.